Hi, my name is Hafiz. In this video, I'm going to talk about logic gates. In English, we call it as a Tarkika Dwara, which is another phenomena in ICT technologies. These logic gates are mostly used for the designing of electrical circuits. And in an electrical circuit design, there are a lot of logical gates being included. So these logical gates are just for the design purpose, but in physically, we use transistors, diodes, and resistors to implement this in physical devices. There are a set of categories in these logical gates. So mainly, we can divide as basic gates and universal gates, but there are some others as well. So in this video, I am going to discuss about basic gates. In basic gate, we can see there are three operators: and gate, or gate, and not gate. And in universal gates, we can see no gate, NAND gate. So these universal gates, nothing but it's a combination of these basic gates. So if you take this no gate, it combines these not and or operators. And if you take NAND gate, it is a combination of and not gate. Other gates also available like X or XNOR. In this video, I'll describe only about basic gate. I'll to make this video short as possible. I'll try to do a second part of this video to include other types as well. Now let's talk about the AND gate. Here, in the left figure, you can see this is the symbol how we represent an AND gate. So here it will be like a half of the oval shape, and from the front two lines it indicates the input and output, input data, and the right side line it indicates the output. In logic gates, we have this input that comes into the gate, and we have outputs that goes out from the gate after a certain processing being done on the input data. For these gates, we handle data in binary numbers. So I have done a separate video about binary numbers in my numbering systems video. I'll link that video in here. There are since this is dealing with binary numbers, there are only two numbers are available, that is 0 and 1. So for logic gates, the data will represent in zeros and 1. On the right side, you can see an example. So here you can see the binary digits are getting as inputs, and there will be a processing done, and the output will be produced. Let's see how AND gate reacts to the input data. So basically in AND gate, it multiplies these input data to produce the output. So for example, if you insert 0, first data as 0 and second data as 1, then 0 multiplied by 1, it's 0. The output will be 0. If it is 1 and 1, then the output will be 1 multiplied by 1, it's 1. So that's how the AND gate works. It actually multiplies with each other. Let's see the logical table of the AND gate. So if you take this first data as A and second data as B, then the output will be A into B. So we in AND gate we represent the multiplication as A dot B. So for A, if you insert 0, and for B, if you add 1, then 0 into 1, it will be 0. And likewise, if you put insert 1 as data A and 0 into data B, then 1 into 0, it's 0. So if you pass 0 and 0, it will be 0. And if you pass 1 and 1, it will be 1. So this is how it works. So actually these zeros and ones are like it's electrical pulses. 0 means there's no electrical pulse being sent through these circuits. If it is 1, then that means we are sending an electrical pulse through the circuit. So that's how the electrical circuits work. It's basically on and off. Zeros and represented by zeros and 1. Next, we talk about the OR gate. This is how the OR gate is being represented. It's something like a alien spaceship. So this is the symbol that is represented for the OR gate. So like you saw in the AND gate, in here we actually adds the data to produce the output. So in the previous AND gate, we multiplies the data to produce the output, but here we adds the data to produce the output. For example, if you pass 0 as the A value and 1 for the B value, 0 plus 1, the output will be 1. And if you pass 0 and 0 for both values, then you will get a 0 output. Let's see how the logic table looks like. So if it is 0 and the B value is 1, 0 plus 1, 1. And if it is 1 and 0, it's will be 1. 0 and 0, it's 0. And here, if you take 1, both data is 1 and 1. So actually 1 plus 1 is 2, but since this is we are dealing with binaries, we consider this 2 as 1. So that's how the logical gates looks like. So actually you don't have to remember these tables. So just you need to understand how the logic works. So in high level, if it is AND gate, you need to multiply. And if it is OR gate, you need to add add the data to produce the output. So our last gate will be the NOT logical gate. So this is the electrical circuit representation of the NOT gate. So NOT actually gives the opposite of the input value. So whatever you pass into the gate, it will give the opposites. It's like we can consider as an inverter. So if you pass A, you will get the A bar. If you pass so for A, if you pass 0, you will get 1. If you pass 1, you will get 0. This is the high level of the logic gates that we talk in the fundamentals of information and communication technologies. Okay, so we'll see in my next video. Thank you.